Good morning. Today we are going to look at our last lesson in Unit 11, and it's about geometric series. We did arithmetic series, and now we're doing geometric. So, jumping right in, to find the sum of a finite geometric series, we're going to use this formula here. This formula is going to be the one that we use, but the key is that it has to be a finite geometric series, but we can use this formula here. Same kind of same things that we're using, variables a sub 1, r, and n. These are all the same as in the geometric sequences. So remember, sequence versus series. A sequence is just listing the numbers with commas. Series is listing the terms with pluses and adding them all together. So to evaluate, or it says to evaluate the series, and so that means that we get to use this formula here. So we're going to do S sub n equals, and I don't have this one quite memorized, equals a sub 1 times 1 minus r to the n all over 1 minus r. Be very careful here. Don't think that because there's an r and an r that we can cancel things out. We looked in a couple units ago about why we cannot cancel any of this. So this is the formula in its entirety that we need. So to evaluate the series, we could just add things up, but let's practice with this formula. There's 1, 2, 3, 4, 5 terms. So n equals 5. And so we need our first term, and that's negative 45. And then the only other thing we need is the common ratio. One thing you might notice is that the signs are changing each time, negative to positive. So that means that my ratio has to be a negative number, because if I just multiply by a positive, the sign, whether it was negative or positive, would stay the same. If you're not sure what the ratio is or what we multiply 45 to get 135, you can do 135 divided by 45, and that will give you your ratio. If I do 135 divided by 45, I'm going to get 3. So my answer is going to be negative 3. Now, subbing in what I know, I am doing S sub 5 equals negative 45 times 1 minus negative 3 in parentheses to the 5th power all over 1 minus negative 3. Well, let's do a little simplification here. Negative 3 to the 5th power, let me just double check. Yeah, it's negative 243. So we would have negative 45 times 1 minus negative 243, but that would be 1 plus 243 all over 1 plus 3. So we're going to have negative 45 times 244, which would give us negative 10,980 all over 4. When you divide those, we would get that S sub 5 equals 2,745. Now some of you are saying, that's too much work. I can just go up here and put all this in my calculator and it'd be so much faster. And you're right. But I do want you to practice with this formula, because this formula in the long run will make your life easier, because if I asked you to find the sum of, I don't know, like 15 terms, you don't want to add all those together. This will end up being a little faster. And in your calculators, a lot of time, most of you are going to be able to put like all this in as is. I'm taking the time to show each step so that we're seeing where each of these numbers are coming from. So some of you may be able to just use your calculator to get straight from here to here and may be able to eliminate all this in between. Okay? So for example, look, n equals 15. So we know that n equals 15. We know that a sub 1 equals 4. And we know that our common ratio is 3. We're multiplying by 3 each time. So we're going to have S sub 15 equals the first term, which is 4, times 1 minus r to the nth power all over 1 minus r. Oops, there we go. All right, so we need 3 to the 15th power. Yikes, that's a big number. So let me check and see what I'm going to get here. Some of you may get an E, and that's okay. But hopefully you get this. I'm going to, again, show my work. 4 times 14,348,907 all over negative 2. Oh, sorry, 1 minus that. I forgot the 1 minus. So now we have equals 4 times negative 14,348,906. I'm going to get negative 57,395,624 all over negative 2. And so my final answer will be 28,697,812. And really what we should do is write it like this, s sub 15 equals the big number, because we want to answer the question of what is the sum of the first 15 terms. So I'm going to put it as this actually instead of this over here. And that's it. I got my over negative 2 over here. All right. So here are some key terms. With arithmetic sequences and series, they just continue to grow. But with some geometric series, we can have infinite geometric series, and that means they continue forever and forever. They continue infinitely. So what we have to look at in this case is the ratio. If the absolute value of the ratio is less than 1, then that means that the series converges, and that means that we think about converge as like two things that are getting closer and closer and approaching one another. Versus if the common ratio is equal to 1 or greater, then the series are going to diverge, and that means that they're going to go maybe like this, and they're going to go opposite directions of each other. You might have heard this word a few more. There's like the book series divergent. You're diverging from what is considered the norm. There's a famous poem that says 2 roads diverge in a yellow wood. And that means that these 2 roads are going like this and going away from each other. But yeah, anyway, so this is converge and diverge. If an infinite geometric series converges, the sum is this. And that's a lot easier to do. Really, it's just taking out this part of the other formula. It's the same thing, but just taking that out. If the series diverges, then there's no sum. If the series diverges, there's no sum. So determine whether each series diverges or converges, and then state whether each series has a sum. So I'm looking at these and saying, okay, what's my common ratio? What am I multiplying by each time? And if I think about this as 3 over 1, I can see a pattern here. I'm not changing my numerator at all. So thinking in terms of multiplication, I'm going to say that I'm multiplying by 1 over something. If I multiply 3 times 1, I get 3. 3 times 1, I get 3. So just multiplying by 1 keeps that numerator the same. In the denominator, I can see that my pattern is that I'm multiplying by 2. I'm multiplying by a half every time. So this value, the absolute value of 1/2, is less than 1. So that means that this converges. And yes, it has a sum. That's all you got to say is yes. You don't have to tell me what the sum is. For this one, it's still a geometric series, but we are going to look at what are we multiplying by every time. I don't know about you. Off the top of my head, I don't know what I multiply by 6 to get 11.4. So I'm going to say, what's 11.4 divided by 6? And if I do that, I get 1.9. And if I check it, is 1.9 times 11.4 21.6? Yes, it is. So I'm looking at the absolute value of 1.9. That is greater than 1. So it diverges. And if it diverges, it does not have a sum. That's it. All right. Evaluate the infinite series. So our formula for that is S sub n, or well, I guess it'd be, yeah, equals a sub 1 all over 1 minus r. So we need to look at our first term and we need to look at our ratio. The first thing I always recommend doing is starting with that ratio. You might remember that the formula for a geometric sequence is a sub 1 times r to the n minus 1, and that's what's going to go right here. Now there's no number in front of this, but it's like having 1 times that. So I'd be saying that the first term is 1, but my ratio is negative 2.1. If I check that and take the absolute value of that, that's greater than 1. So therefore, this diverges, and we would say, nope, nice try, but there's no sum. Can't do that. And this would be your answer. If we look at this one, we have to figure out what's our common ratio. Again, it looks like our top number is staying the same, so we're going to have a 1 over, what are we multiplying by in the denominator? 2. So our ratio is 1/2. Our first term is 1. So we're going to get the sum equals 1 over 1 minus the ratio. So 1 over 1/2, which equals 2. And what that means is that really we're never actually going to get exactly equal to 2, but it means that if you want to think about like a graph, it's kind of like an asymptote where our value, maybe it's at 2, and our values are going to get really, if we have this value of 2 here, our values are going to get really close to 2. It's never actually going to touch it, but we can say, it's basically the same thing. It's basically 2. So that was how we would do that one. Let's do one. Oh, no, not one more. I thought I had one more. Sorry. This is not actually your homework. Your homework is posted in Google Classroom. You'll be practicing these different skills, and I'll be on Zoom, so holler if you need me and ask any questions that you may have. Thanks, guys. Have a great day.